I'm Lawrence Sandler. I'm Director of Applications Engineering for EPIQ Solutions. So EPIQ Solutions is an SDR vendor, as most of you know, and we do a variety of SDRs and SDR platform products. Pretty much anything from small embedded SDRs through 1E racks with pretty much everything in between. What are we seeing in the market today? We're seeing a progression of the radio front ends. So we're going from relatively lower bandwidth for today's standards, from like 50 meg type instantaneous bandwidth, through to multiple hundreds of megahertz, to gigahertz, to even multi-gig IBW, instantaneous bandwidth per channel with multiple channels. And so you see that graph with the line that goes up in a sort of exponential fashion. That's the digitization capability of the front end. And you see the straight line that goes up, but not quite as fast, and that's your compute capability. So traditional CPUs are not tracking quite as well as the RF front end is able to present you data, right? So how do you deal with that? Well, one option certainly is you go off track a bit and couple your CPUs to GPUs, and you incorporate some AI ML, and your ML packages essentially help you with the properly enabled hardware. Another dynamic in the industry that we see is more requirements for edge devices. So traditionally, you take a front end, you stream it to a high performance processing unit of some sort, and you build your solution that way. If you have an edge device, you don't have that large pipe back to a remote capability for processing. So you need everything local. So it's important to get into a relatively small footprint to get all your assets out at the edge of the cloud. So some applications that we use include some CPU intensive applications and some ML intensive. One of the ML packages we use is from a company called DeepSig. Both EPIQ and DeepSig have booths in the expo area. If you haven't stopped by before, please come by, and we're running demos. But basically what I'm presenting here is new platforms that we have that integrate the radio front end, and they all are multi-channel and Orin NX processors. So if you're not familiar with Orin NX, it basically gives you the CPU piece with 8 64-bit ARM processors, and then it couples it to GPU fabric, both Tensor and CUDA cores, and you get 100 TOPS of GPU potential in those devices. We have the G20 and G40, and those are multi-channel 50 meg IBW per channel devices, and then you move to the X40 and you go up to 200 or 450 meg per channel, multiple channels that can also extend all the way up to 18 gig and give you a significant amount of FPGA fabric. This is what a G40 looks like internally. We don't have enough time to go through this, so I'll just pop it up, and if there's any questions, please come by our booth. I'd be glad to address that. The X40 is pretty interesting in that we offer it in a couple different forms. The original one was built to insert in a 2.8-inch tube, and that was a very particular application, but we make a rectangular version that's available, and that gives you a lot of performance in that package size. I think I've probably used my 5 minutes. So thanks, everyone, and stop by if you can.